You all know that every time you throw something up, it comes back down. But why? Why does everything we throw in the air just come right back down again? Why is that? It's because of a particular force. If we throw a ball into the air, for example, and it falls down again, it's because of this force. But this force is something we can't see. Yep, I'm talking about gravity. And I'm here to tell you all about it. Maybe you've heard of gravity before, but what actually is it? Gravity is an invisible force. We can't see it, but it pulls on everything that has mass. For example, that includes people like you and me. When I jump, I don't float, I get pulled back down again, and that's gravity. Just like when I threw the football up and it fell down. That's gravity. When jugglers throw balls upwards and they fall down into their hands again, that's gravity. Every object around us has mass, and a football, for example, has the same mass whether it's here on Earth or up on the moon's surface. But the weight of the football here and its weight on the moon are different. Throw a football in the air here on Earth and you'll see gravity pull it down again quickly. Do the same on the moon though, and the football will be pulled down to the ground much more slowly. But remember, the football's mass is the same in both places. The football returns back down on Earth far quicker than on the moon, which has a lower gravity, so the ball floats down more slowly. How do you know the weight of an object? The equation we use is W for weight, m for mass, times g for gravity. W equals m times g. And to measure weight, we can use either grams or kilograms. The more mass an object has, the more gravity will pull things towards it. Now, what's the most massive thing you can think of on Earth? What do you think? Yep, it's the Earth itself. Bet you didn't think of that answer. That was a bit of a trick question. Because of how massive the Earth is, gravity pulls other things towards it. Here we can see an astronaut. On Earth, gravity means that you and me are pulled towards the ground, but an astronaut, all the way up there far away from Earth, can float in space. That's because there is a much lower gravity pulling on them. Remember that here on Earth, the gravity is quite high and powerful. All the planets and moons like the ones here behind me have their own gravity. How strong the gravity is depends on the mass of the planet or moon. More massive planets will have a stronger gravity than other smaller ones. Jupiter here is an absolutely huge planet. And if I were to travel here, its strong gravity would pull me right down. But if I traveled to the moon here, I'd be happy. And you know why? Because I could jump and leap and bound around the surface and float around. Just like the astronaut. Even though they have a heavy, thick spacesuit on, they can still float, hop, and jump long distances. This is because the moon has a lower mass than the Earth. And that means that gravity affects you more on Earth than when you're here moonwalking. Back on Earth, we still have this strong gravitational pull. How can we beat gravity and not get pulled back down? Ah, a rocket. But how can a rocket beat gravity, travel into space and not get pulled down again? It uses a great blast of gases and heat to create a force upwards that is stronger than the force of gravity pulling it down. It shoots into the air, into space, and that's how you beat gravity.